So right now we brushed up quite a lot about sets, relationships, functions, Venn diagrams. Let's take a final quiz as a comprehensive exercise and see how much we have actually conducted. I would exhort children to keep, or candidates to keep, a pen and paper in hand so that you can seriously sit and work. Doing the final quiz will definitely help you a lot. Let's see what we have here. Okay. In a town of 20,000 families, it was found that 40% families buy newspaper A, 20% families buy newspaper B, and 10% families buy newspaper C. 5% families buy A and B, 3% buy B and C, buy A and C, 2% family buy all the three. Then the number of families which buy only A. So in a town of 20,000 families. Now the number is not very important. Since everything is given in terms of percentages, we will take it as 100 as the total. Right. So 40% families buy newspaper A. So this is 40% buy newspaper. Now we are not concerned about this. 20% families buy B. So this is 20%, this whole thing. And 10%. 5% families buy A and B. So this whole thing is 5%. This whole thing, A intersection B. So since N of A intersection B is 5%. Now you need to find the number of families which buy only A. So we need to find this part of it. This portion is what we are interested in finding out. So that is going to be the whole A minus this, minus this, minus this. So now this whole thing is 5 and this alone is 2. That is 2% families buy all the three and 5% family buy A and B. So exactly 3% will buy A and B but not C. Similarly, A intersection C, the ones who buy A and C is 4%, that is this much is 4%. Out of which 2% buy also B, so the ones who buy A and C, only A and C but not B is going to be 4 minus 2, that is 2%. And A alone is 40%. So this much is 40 minus 2 minus 3 minus 2. That is 40 minus 7. 33% of the family, 33% of families. If it's not mentioned, it is assumed that everybody buys at least one of the newspapers. So 33% of the total number of families read only A, but in terms which buy only A. So buy only A. So this is in terms of percentage. The total number of families is 20,000. So it is going to be 33% of 20,000 families buy only A, which turns out to be 6,600. So 6,600 families buy only A. Understand the difference between buying A and buying only A, which means they buy A and no other newspaper. So it's 6,600, which is this one. Okay, so we have it right there. From here, we move on to the next one. Then, f of r, that is function of r into r, be such that f of x is 2 raised to x, then f of x plus y equals to what? So f of x plus y would be f of x plus y would be 2 raised to, instead of x you put 2 raised to x plus y, which is 2 raised to x into 2 raised to y, and this is nothing but f of x into f of y. So f of x plus y is nothing but f of x into f of y. That is option number B. Let's see what we have. Yes, we do have it right here. Okay. Then we have this situation again, a Venn diagram. Out of a total of 150 students, 45 passed in accounts, 30 in economics, 50 in maths, 30 in both accounts and maths, 32 in both maths and economics, 35 in both accounts and economics, 25 students passed in all the 3 subjects. Find the number who passed at least in one of the subjects. Now here, if you look at it, unlike the previous questions, candidates, that all the questions have been jumbled, it is just a challenge for you to keep switching from one concept to another. Before this, we did about relationship and function. Now again, we have jumped to Venn diagram. We may move over to something else, so that it is a good jostling and racking of the brain to how you are able to switch off from one concept to another. Anyway, coming back to this question, find the numbers who passed at least in any one of the subjects. So which means you need to find n of A union E union M. So it is a situation like this. We have 3 circles. So out of a total of 150 students, so there are totally 150 students, 45 passed in accounts. So this is say accounts, this is English, this is maths. 45 passed in accounts. So this is 45. So n of A is 45. And n of E is 30. And n of M is 50. 30 in both accounts. So n of A intersection M is 32, and n of A intersection E is 35, and 32 maths 30. N of A intersection M is 30, 32 in maths and economics, that is M intersection E is 32, and N of 35 in accounts and economics is 35. So N of A intersection E is 35, which means the number who passed. Then N of A intersection M, E intersection M, is 25. So you have been asked to find how many passed at least in any one of the subjects. So N of A out of 1, A union M union E. That means out of these 150 students, there may be people who may not have passed in any of them. We are not concerned about them. We are concerned about the ones who passed in at least one of the subjects. It will be N of A, that is 45, plus N of E, that is 30, plus N of M, that is 50, minus N of A intersection M, that is 30, minus N of M intersection E, that is 32, minus N of A intersection E, that is 35, plus 25. This of course gets cancelled. So we have 45 plus 50, 95, and we have 95. We have 120 minus 67, which turns out to be 53. So there are 53 of them which belong to anyone. Obviously, the total is 150. So the remaining 150 minus 53 pass in not even in one of the subjects. Hence, the answer is 53 of them who pass at least in one of the subjects. And hence, we have that case. Yes, we do have it as 53. Okay. Then we have a situation here. A is 1, 2, 3, 4, B is 2, 4, 6, 8, F of 1 is 2, F of 2 is 4, F of 3, and F function of A to B. Then F minus 1, that is the inverse relationship, will always be the relationship which will have the domain and the range interchange. So it is going to be 2, 1, 4, 2. Here it is 6, 3 and 8, 4. This is the inverse relationship. 2, 1, 4, 2, 6, 3. That means this was y, this was x. So the inverse relationship, which was original relationship, was x, y. Now it will all be y, 1. 2, 1, 4, 2 and 6, 3 and 8, 4 will be the inverse relationship. So among these, it's this which is the inverse relationship. Yes, we do have it there. Okay, then f of x is 2 plus x upon 2 minus x. We go back to the original one. F of x would be equal to 2 plus x upon 2 minus x. So we need to find out what x is. So cross multiply, you get 2 times f of x minus x into f of x is equal to 2 plus x. Take this to this side, so you get 2 times f of x minus 2 is equal to x minus x into f of x. So we can write this as x bracket 1 minus f of x, and this is 2 bracket f of x minus 2. So hence this can be now written as 2 times f of x minus 1 divided by 1 minus f of x is equal to x. Now as usual, what do? We change it to, this will become now 2 times 1 minus f of x. Let us check what we have here. 2 times, it should be, oh yeah, we made a mistake here. It should be x plus, so it should be x into, so this will also be 1 plus f of x. So this x becomes f inverse x, and f of x becomes x. So it becomes 2 times x minus 1 upon 1 plus x, or x plus 1. So f inverse x will be 2 bracket x minus 1 upon x plus 1. That is option number A. So what we have done is we have just rearranged the terms, eliminated and found out the value of x. So we expressed x in terms of y. Y is the same as f of x. Hence, instead of f of x, you put back x and y becomes this. And yes, we do have it as 2 bracket x minus 1 upon x plus 1. So we have a situation wherein you have f of x is x square plus x minus 1, and 4 times f of x is f of 2x. So which means 4 times f of x means 4 times x squared plus x minus 1 is f of 2x, which means 2x the whole square. That is, in this relationship you substitute 2x in place of x, 2x minus 1. So this gives you 4x squared plus 4x minus 1 is equal to 4x squared plus 2x minus 1. So f of 2x. So we have 4x squared get cancelled, and x squared plus x minus 1. Oh, this is, I'm sorry, made a mistake. So it's going to be minus 4. So hence you get 4x minus 2x is 2x, minus 1 plus 4 is 3, and x would be equal to 3 upon 2. So the value of x is 3 by 2 if 4 times f of x is equal to f of 2x. So it's going to be option number B, and yes, it is option number B. Okay. Now furthermore, we have f of x is 2x plus h. Find x plus h minus 2 times f of x. Now f of x plus h minus 2 times f of x. Now f of x plus h will have 2 times x plus h, that is, instead of x, you're putting x plus h, plus there is an h, minus 2 times 2x plus h, 2 times fx. This one opening the bracket gives you 2x plus 2h plus h minus 4x minus 2h. So we have 2h and minus 2h getting cancelled, and 2h and 2h, so you end up getting minus 2x minus plus h, or it can be h minus 2x. So it is h minus 2x is the correct option, and we get it as h minus 2x. That is option number A. Yes, we do have it right, h minus 2x. Okay. Next in waiting is function of a to r is a real valued function defined by f of x is 1 by x. then that means if you from A to R, that means the domain is okay for all real values of x except when x is equal to 0, because the moment you put x as 0, f of x becomes, if x is 0, f of x is meaningless, which means this relationship is true for all relationships, for all those values of x except when x is 0. So all the real values minus 0 are acceptable. So that means the answer over here is f of x. It's a real valued function, meaning it is a meaningful function provided x is not 0. So the domain should contain all real values minus 0, that is except 0, right? So we have it accordingly. Okay, now f of x minus 1 is x squared minus 4x plus 8. So what we need to do over here is that we need to first convert this into a function which has x minus 1 the whole square. So let's see, if you see f of x minus 1 is x squared minus 4x plus 8. So if you see, this can be now written as x squared minus 2x minus 2x. We have split up the minus 4x plus 1 we have added. So we have to subtract also minus 1 and get it as 8. Now why are we doing this? We're going to express this whole thing in terms of x minus 1 the whole square. Now why do we do that? Now there is one x minus 1 the whole square here. So this will become x minus 1 the whole square minus, this can be written as minus 2x plus 7, which can be now written as x minus 1 the whole square minus 2x, and you need to split this up as plus 2 plus 5. We are splitting up 7 as 2 plus 5, right? What have we done here? We are splitting up 2x as 2x and minus 2x, and then added 1 and minus 1, so that this becomes x minus 1 the whole square. Now let's see what we have over here. This becomes x minus 1 the whole square minus 2 into x minus 1 plus 5. That means f of x minus 1 the whole square is expressed in terms of x minus 1 the whole square. Therefore, in that case, f of x plus 1 the whole square would be what? It will just be x plus 1 the whole square minus 2 into x plus 1 plus 5. This is what will be, or you can change it to f of x would be x squared minus 2x plus 5. Hence f of x plus 1 would be x plus 1 the whole square minus 2x plus 1, which is what is required. So we write it as x squared plus 2x plus 1 minus 2x minus 1 plus 5, and hence this gets cancelled, and minus 2x minus 2, I'm sorry. So this will become 6 minus 2. So this will give you x squared plus 4. So what we have done is, the function which contains only x squared will convert it into a function which contains x minus 1. So there is an x minus 1 the whole square. So this becomes a function of x minus 1, f of x minus 1. Now in this expression, replace x minus 1 with x plus 1 to give you function of x plus 1, and that turns out to be x squared plus 4. And hence the correct option is C, that is x squared plus 4. Definitely it's the same. Okay. Then, alright. So now we have one more case. F of x is 3 plus x for the domain greater than minus 3 to 0. And it will be 3 minus 2x when the domain is from 0 to 3. Then value of f of 2. Now f of 2 means now 2 is not between minus 3 and 0. It is greater than 0. So it is in this range. Hence we need to consider this particular function, because so this, when the domain is 2, the range relation function is this, not this. Suppose it was told f of 1, we would use this. But here is told it's f of 2, so it is this function that is valid. So f of 2 hence would be 3 minus 2 into 2. That is 3 minus 4, which is minus 1. So it's going to be minus 1 here. Right? Yes, we do have it as minus 1. Okay. Now we have a very interesting question here. For a group of 200 persons, 100 are interested in music, 70 in photography, 40 in swimming. Furthermore, 40 are interested in both music and photography, 30 in both music and swimming, 20 in photography and swimming, and 10 in all the three. How many are interested in photography but not in music and swimming? So this again is concerned with 3. Let's see. We have 3 cases. We have music, we have photography, we have swimming. So there are 200 people, 100 are interested in music. So there are 100, 70 in photography and 40 in swimming. Furthermore, we have been asked how many are interested in photography. They are interested in this but not in music and swimming. So our target is this. Hence, we need to find this and subtract this from P. So we need to first find M intersection P. So 40 are interested in both music and photography. So this much interested in music and photography, and 10 in all the 3. So 10 are interested in all the 3. 40 are interested in music and photography. So the number who are interested in only music and photography but not in swimming would be 30. Then the number interested in photography and swimming. So 40 and 20 and have photography and swimming. There are 20 interested in photography and swimming. This 20. Out of which 10 are also interested in music. So only 10 are interested in both photography and swimming. So 20 are interested in photography and swimming, which also includes the ones who are also interested in music. So there are 10 who are exclusively interested in just photography and swimming, 10 interested in all the 3, 30 interested exclusively in music and photography. And the total who are interested in photography is 70. So this much alone, the ones who are interested in photography alone and not in music and swimming would be 70. This total 70 minus 30 minus 10 minus 10, which would be 70 minus 50. That is 20 of them are interested exclusively in photography. That is only in photography but not in music and swimming. So our man is 20 here. Yes, we do have it as 20. Furthermore, we have this kind of a sitch. F of x is x plus 2, g of x is 7x plus 2, then g of that is g of f of x. That means the basic function is going to be this, and instead of x you're going to put 7 raised to f of x. That means 7 raised to x plus 2, which would be 7 raised to x into 7 square, which would be 49 into 7 raised to x. So among these, this is the answer. So g of f of x is 49 into 7 raised to x. Yes, we do have that. Furthermore, we have an interesting case. We have an f of x which is log 1 plus x upon 1 minus x. F of 2x is upon 1 plus x square. That means f of 2x upon 1 plus x square means f of x is this log, and instead of x you're going to put this. So it's going to be 1 plus 2x upon 1 plus x square upon 1 plus 2x upon 1 minus x square. That is, instead of x you are substituting 2x upon 1 plus x square. This turns out to be log. Taking LCM, you get 1 plus x squared plus 2x upon 1 plus x squared upon 1 minus x squared 1 plus 2x. We have 1 minus, okay, we made a mistake here. It's going to be 1 minus 2x upon x plus. So it's going to be 1 plus x squared minus 2x upon 1 plus x squared. What we did here was, this is instead of x, you're putting this f of x, and again here you're putting this, and the sign here is minus. These two get, of course, cancelled. If you see, this turns out to be log of a square plus 2ab plus b square, which is 1 plus x the whole square, upon a square minus 2ab plus b square, which is 1 minus x the whole square, which would turn out instead to log of 1 plus x upon 1 minus x the whole square. As per the rules of log, this will turn out to be 2 log 1 plus x upon 1 minus x. Is the most simplified form. But this log 1 plus x upon 1 minus x itself is f of x. So this will become 2 times f of x. So that means f of 2x upon 1 plus x square is nothing but twice f of x. So do we have it here? Yes, it is twice f of x. Right. It is twice f of x.